Hello, my name is Amer Youssef. I'm working with Dr. Kishinsky and Dr. Bofa on lipoprotein little a, or known as LPA. And we're interested in LPA biosynthesis because it is the single most prevalent inherited risk factor in cardiovascular disease and is an independent and causal risk factor in atherosclerotic cardiovascular disease and calcific aortic valve stenosis. Also, elevated LPA levels is prominent in 20% of the global population, and yet there is no effective clinical treatment, only promising clinical trials. However, it has been shown that treatments lowering low-density lipoprotein cholesterol, LDL cholesterol, can also reduce LPA levels by 30%. This is possible due to the structure of LPA, which is composed of an LDL-like particle containing an ApoB protein wrapped around a lipid moiety. But what distinguishes LPA from LDL is the presence of the glycosylated multi-kringle protein known as apolipoprotein little a. These two protein components produced by the liver interact first non-covalently via the weak lysine binding sites in kringle 7 and 8, followed by the covalent interaction via a disulfide bond, which is a single disulfide bond. Here's in this talk, my main question is to signify what the effect of the non-covalent interaction in mediating the production of LPA and secretion, and whether the lysine binding ability in kringle 7 and 8 affect LPA biosynthesis. For this, I did a co-immunoprecipitation on cell lysates and media from HepG2 cells transiently transfected with physiologically relevant 17 kringle ApoA or 17K delta LBS 7-8, the ApoA variant with amino acid substitutions that abolishes lysine binding in kringle 7 and 8 required to interact with ApoB. The pull down was done with an anti-ApoB antibody, and the immunoblotting was detected by an anti-ApoA antibody. The samples were run in non-reducing conditions in the media, and that shows that the covalent complexes were present in media only with the wild-type 17K and not with the 17K delta LBS 7-8. Also in the lysates, in reducing conditions, the non-covalent interaction was significantly lowered with the 17K delta LBS 7-8. This supports that non-covalent interaction is mediated via the lysine binding ability of ApoA for the interaction with ApoB. Second, to confirm the interaction, I utilized a proximity ligation assay to show the physical interaction in the physiological cell between ApoA and ApoB intracellularly. It was visible that the density of red punctate signal per cell with wild-type ApoA 17K is higher as compared to the 17K delta LBS 7-8. This provides a direct evidence that ApoA-ApoB interaction is facilitated by lysine binding sites that is required in LPA biosynthesis. Finally, in part, this talk can explain why ApoB lowering agents like mipomycin and lomopatide can also lower LPA levels, and such understanding can help in finding LPA-specific lowering therapies. Thank you for listening, and please attend to my poster for extra information that are very exciting. Thank you. Bye.